All right, Algebra 1, this is a video for Monday. We are on day 6 of section 4, and today's notes is on the average rate of change, all right? It comes from our new packet, which this is our new packet. And you'll notice it says, after today, you should be able to describe the difference between linear and nonlinear rate of change. You should be able to calculate the rate of change between 2 points when you're given a graph. You should be able to calculate the rate of change between 2 points when you're given a table. You should be able to conclude or calculate the rate of change from a word problem and interpret the rate of change, all right? So here is our notes for today. So notice up here, what is the average rate of change? And we're going to use ROC kind of for a short. The average rate of change, or the slope, all right? That's what it is. The average rate of change is the same as the slope. It's the ratio of the change in y to the change in x over a certain interval. So you've had a teacher in your past tell you that the slope is your rise over run. It is the change in y over the change in x. So it's the change in y is your vertical change, your up and down change over top of your horizontal change, which is your left and right change. And so that's why the equation is y2 minus y1 over top of x2 minus x1. In other words, the second y minus the first y over top of the second x minus the first x, all right? And so to find the rate of change using a graph, a function's rate of change can be constant or linear, it stays the same, or it can be exponential where it's changing. So constant linear means it's the same, like my pen is the same slope. As you go so many units to the right, it's going so many units up, or as you go to the right, it's going so many units down. So it's linear, it's constant. Up 3, right 1, up 3, right 1, up 3, right 1. But when it's exponential, it's a curve, all right? So because it's a curve, it's always changing. It varies. And so when the function is linear, the rate of change is constant. Like I said, up 3, right 1, up 3, right 1, or down 2, right 1, down 2, right 1, down 2, right 1. But when it's curved, the rate of change varies. Maybe it first goes up 2, right 1, and then it goes up 3, right 1, and then it goes up 5, right 1, and so on. So it's like it curves and it's getting steeper maybe, okay? On a graph, count between the 2 given points or the given interval, okay? So then the next section here says, what about, how do you know the difference between a positive rate of change or a negative rate of change? Well, the positive rate of change, just like when you learned back in the day, a positive slope is a slope that's going increasing, it's uphill, all right? So it's an interval where the graph is increasing, all right? And a negative rate of change indicates an interval where the graph is decreasing, going downhill, okay? So a positive rate of change is like going higher and higher and higher from left to right, okay? And a negative rate of change is going downhill, decreasing from left to right, okay? So here's some examples that we're gonna look at. Okay, the first one. So as you can see, it's a line. And so if you were to kind of look at its slope between 2 points, as you go up 3, 1, 2, 3, that's up 3. How many units to the right are you going? 1, 2, 3, 4, 5, 6, 7, 8, 9. Up 3, right 9. So remember, it's the change in y over the change in x. So 3 over 9, the rate of change then, that simplifies to 1 over 3. Up 1, right 3, boom. Up 1, right 3, boom. Up 1, right 3, boom. So every time this slope is up 3, right 1, up 3, right 1, up 3, right 1. So it's constant because it's a line, it's linear, okay? Same with number 2. As you can see, it is going down 1, 2, 3, 4, 5, 6, and right 1 and 2. So down 6, right 2, down 6, right 2, down 6. Well, when you reduce that down 6 is really a negative. So negative 6 over 2 simplifies to negative 3 over 1, which means every time you go down 3, it goes right 1. Down 3 more, right 1. Down 3 more, right 1. Okay? Both of those are linear because they're lines, because the rate of change was constant. Okay? Here's 2 more graphs. Notice here, as you can look at this graph, it's curved. So whenever you have a curve graph, that's going to be changing. All right, so that's like exponential. It just changes. It's not going to be always the same. All right, so what they want to know is they want to know what the rate of change is between the interval. This is showing an interval between when x is negative 3. So where is x at negative 3? Right there. Where is x at a positive 2 on the graph? Right there. So they want to know the slope of that. So in other words, the slope between those 2 points is going to be, what's that average rate of change? Okay, so we want to find how far does it go down and to the right from there. So it's going down 1, down 2, down 3, down 4, down 5. And then it's going right 1, 2, 3, 4, 5. So the down 5 and right 5, so that's like saying down 5, negative 5, and right 5 is positive 5. Well, that just equals a negative 1. Okay? But see, that graph is a curve. And here's another curve. If you look at this one, see, the rate of change down here is really small because it's not a steep curve. But as you go more to the right, it gets steeper and steeper and steeper. So this rate of change is always changing. It's varying. Okay? But they want you to find the rate of change between when x is 0 and when x is 2. So where is the graph at x equals 0? It's right there. Where is the graph at x equals 2? Well, it's going to be way up here. So what is that average rate of change? See, I'm drawing a straight line between those 2 points, but the actual graph is curved. And so to find the average rate of change, I go up 1, up 2, up 3. And I'm going over to the right, 1 and 2. Well, up 3 is a positive 3. Right is also going positive, so 3 over 2 is that rate of change. So it's real easy from a graph to find the rate of change between 2 points. Remember, you put the change in the y over top of the change in the x's. Okay? All right, let's go to the back side of this page. So now on the back side, they're going to give us some examples that are in table format. Okay, so like on number 5. This table, the temperature. In 2 hours, the temperature was 4 degrees. 5 hours, then it was 13 degrees. 9 hours, it was 25 degrees. 11 hours, it was 31 degrees. Okay? So what I'm showing you here is these are our x's, remember, and these are our y's. So from 2 to 5, that's going up 3. That's 3 more hours, right? It's changing, all right? From 5 to 9, that's a change of 4 hours. From 9 to 11, that's a change of 2 hours. And on our y side, from 4 to 13, that's a change in 9 temperature, 9 degrees. From 13 to 25, it's gone up 12 degrees. From 25 to 31, it's gone up 6. So to find the rate of change, is this formula right here, the second y minus the first y over top of the second x minus the first x. So looking at that, if I have, these are my y's, from 4 to 13, that was up a change in 9 over top of a change of 3. 9 over 3 is 3. Then the next one, so to go from 13 to 25 was a change of 12 degrees, and from 5 to 9 was a change of 4 degrees. So 12 over 4, hey, it's the same, 3. So I'm just kind of showing you how when you're given a table, you can kind of do that, see how the x's are changing and how the y's are changing, and then take the change in y over the change in x to see what that rate of change is. Change of y over the change of x. So the change of the y's down here was 6. The change of the x's were 2. 6 over 2 also reduces to 3. So here they say find the rate of change of the temperature between 2 and 9 hours. So between 2 and 9, notice there's the 2, there's the 9. So if I take the 25 minus the 4, that's the second y minus the first y, 25 minus 4, over top of the second x minus the first x. All right, that 9 minus 2 is 7. So 25 minus 4 is 21 over 7. 21 over 7 equals 3. That's the rate of change. See, I almost kind of think my way is even a little bit easier. Well, what about from the interval of 5 to 11? So I'm going to use a different color pen. Well, here's that, 5. Here's 11. So there's that number and that number. So the second y, 31, minus the first y, 13, over top of the second x, 11, minus the first x, 5. So 31 minus 13 is 18, and 11 minus 5 is 6. 18 over 6 reduces to 3. So they both had the same rate of change of 3. Up 3, right 1. Up 3 more degrees, 1 more hour. Up 3 more degrees, 1 more hour. Up 3 more degrees, 1 more hour. So is the rate of change constant or varying? It's constant. And is the rate of change increasing or decreasing? It's going up. So that's increasing. Okay, here's another table. Notice they give us the equation y equals 2x plus 6. Well, notice something. If we know that rate of change is the slope, this is in slope-intercept form. I already know what the rate of change is. The rate of change is going to be this number right in front of the x. It's up 2, right 1, up 2, right 1, up 2, right 1. And so you can also see it here in the table. If you put a 0 in for x, 2 times 0 is 0, plus 6 is 6. If you put a 1 in for x, 2 times 1 is 2, plus 6 is 8. Put a 2 in for x, 2 times 2 is 4, plus 6 is 10. Put a 3 in for x, 2 times 3 is 6, plus 6 is 12. 4, 2 times 4 is 8, plus 6 is 14, and so on. But notice, what's the rate of change? Up 2, up 2, up 2, up 2, for every time that the x's are going up 1, up 1, up 1, up 1, okay? So here, between 1 and 2 hours, between 1 and 2 hours is right here, so take the second y minus the first y, so 10 minus 8, over top of the second x minus the first x, 2 minus 1. 10 minus 8 is 2. 2 minus 1 is 1. 2 over 1 equals 2. So I'm showing you the way here that the formula is to find your rate of change or your slope. Take the second y minus the first y over the second x minus the first x. But we knew what the rate of change was because this was a linear equation. And it's in slope-intercept, so the number in front of the x is your slope or your rate of change, okay? All right, well, as we go on to answer this, what about between the points 3 and 4? Okay, notice this is not in parentheses, so this is not the point 3 comma 4. This is in brackets, so this is an x value, this is a second x value. So the first x is 3, the second x is 4, the first y is 12, the second y is 14. So if I take the second y minus the first y, 14 minus 12, over top of the second x minus the first x, 4 minus 3. So 14 minus 12 is 2, 4 minus 3 is 1, 2 over 1 equals 2. It is constant, and because there was not a change. Both of the slopes were 2 over 1, 2 over 1. And it's increasing, okay? All right, the last four, 7, 8, 9, and 10. So here's 7 and 8. They give you an equation, and you're supposed to plug in the x values. All right, so this is where you could use Desmos if you wanted to. Remember how we showed you that if you plunk in f of x equals negative 4x plus 10, okay, and then to find f of negative 1, Desmos will spit out 14. And I'll prove it to you without Desmos. If I put a negative 1 right here, negative 4 times a negative 1 is 4. 4 plus 10 makes 14. Okay? Then this is the second x point, positive 3. So from negative 1 to a positive 3, what's the rate of change? So if I put in a 3 in for the x, negative 4 times 3 right there. Negative 4 times 3 is negative 12. Negative 12 plus 10 is a negative 2. Okay? So the change in y over the change in x. And so the second y minus the first y, negative 2 minus 14, over top of the second x minus the first x, 3 minus a negative 1. So that makes negative 16. All right, that's a negative right there. And that is 3 minus a negative 1 makes a positive 4. So negative 16 over 4 is a negative 4 for the rate of change. Okay? But you could have used Desmos if you needed to. Like on number 8, maybe it will be beneficial for you to use Desmos, where you punch in Desmos, f of x equals 2x squared minus 3. And then in the open up the next box down, put in f of 2. And what does Desmos spit out? It should spit out a 5. Keep the same function, but in this, clear out your second box, exit out, and then put in f of 4. F of 4 should spit out a 29. And so the second y minus the first y, 29 minus 5, right there, over top of the second x minus the first x, 4 minus 2. So 29 minus 5 is 24, 4 minus 2 is 2. 24 over 2 spits out 12. The rate of change between 2 and 4 is 12, meaning it's going up 12, right 1, up 12, right 1, up 12, right 1. Okay? And then a couple story problems. Okay? You've traveled a distance of 3,000 miles in 40 hours. Find your rate of speed. Well, remember, rate equals the distance divided by the time, right? If distance equals rate times time, then to find your rate of speed, if I get the rate by itself, I'm going to divide by t. Rate is now by itself. Rate equals distance divided by time. So 3,000 miles divided by 40 hours gets me 75 over 1, which is 75 miles in 1 hour. So every hour you're going 75 miles. Now, is that always going to be the case? Not necessarily. Maybe that first, the first hour or two, you were going 80 miles an hour. And then you started getting a little, tired, and you slowed down, and maybe you started going 75 miles an hour. And then 6 more hours later, and you're going, you're really getting tired, sleepy, and you're going a little bit slower, and so on. But over the whole trip, you averaged 75 miles per hour. Okay? Especially if you're going through Atlanta, in traffic, golly, you might not even be getting over 50 miles an hour, during rush hour. Stop and go. All right, number 10. You have been working at McDonald's for 2 years. Your starting salary was $6.25 per hour, which, holy cow, that's low. Nowadays, you should be starting off with at least $7.50, but nowadays you're getting over, maybe $10 an hour. Some places, because it's hard to find workers, there's people that aren't working, that don't want to work because of the pandemic, and some places are offering like $15 an hour. Okay, So anyway, your starting salary was $6.25 per hour, and now you make $6.49 per hour. Find the rate of change of your salary. So the second dollar amount was $6.49 minus the first dollar amount, $6.25, and that the second year minus the first year. So this is a difference of 24 cents over 1, because 2 minus 1 is 1. So you made 24 cents increase in that next year. 24 cents a year, all right? Not bad. All right. All right, so that is the notes and the examples. So you'll notice here is your homework page. And as right away you can see, tell whether the following graph has a constant or variable rate of change. Well, look at it. It's going up a certain amount over, up a certain amount over, up a certain amount over, up a certain amount over. Is that staying the same? Well, it's not a curved graph, is it? It's straight graph, so that should be easy. Number 2, tell whether the following graph has a constant or variable rate of change. Well, look at is it straight or is it curved? If it's curved, that should tell you whether or not it's constant or variable, okay? 3 and 4 looks like you've got like a little story. What is the rate of change over between when x equals 2 and when x equals 7 for the equation y equals 2x squared plus 5? So this is where you want to like maybe use Desmos and put in f of x instead of y, put f of x equals 2x squared plus 5. And then in the second box below that, put f of 2 and write that number down. Then X out that second box. You keep the same function, f of x equals 2x squared plus 5, and then put in f of 7. And whatever decimal spits out, that's the second one. And so remember, it's the change in the second one minus the first one. Okay? So whatever the second number is minus the first number. Over top of 7 minus 2, remember, second x minus the first x. All right? Number 4, you've been working at the veterinary hospital for 2 years. Your starting salary was $8 an hour, and now you make $10 per hour. What is your rate of increase in salary per year? So the second salary minus the first salary over top of the second year minus the first year. That's an easy one to do. Okay. Number 5, you traveled a distance of 560 miles in 8 hours. Find your average speed. Remember, distance divided by time equals rate. All right, so 560 divided by 8 hours will give you your rate. Number 6, what is the rate of change over the interval from 0 to 2? So 0, when x is 0, your y value is 4. When x is 2, your y value is 8. So the second y minus the first y over top of the second x minus the first x. And that will be your rate of change, okay? Then, on the back side, use the graph to answer the questions. Ooh, look at that graph. All right? Kind of funky. And so on. Number 8, a different graph. All right, actually it looks like it's the same graph maybe. So notice it's probably, this is the exact same graph. Okay, so notice it's at 9 when x is 0, or 9 comma 0 is that point, because that's in the 3-hole punch. Okay. Number 9, answer this question, same graph. Okay. And then number 10, same graph, but it's asking you different questions. All right. And then get into Canvas and do get the assignment done in Canvas. Get these answers put into Canvas. Okay. And hopefully that is good. You'll kick butt on this. All right. All right, so anyway, that is the video for Monday, and I think we've got 2 more days worth of notes, and then we'll have a quiz coming up later, end of the week, all right? Have a great day. Peace out. See ya.